All right, today we're going to trace the epic 70-year journey of artificial intelligence. And let me tell you, it's a story packed with brilliant breakthroughs, some really crushing setbacks, and honestly, some of the most world-changing comebacks in the history of tech.
So the big question is, how did we get from what was basically a simple switch to an AI that can actually reason? It's a heck of a story. It all kicked off with a simple idea, a biological inspiration way back in the 1940s that ended up sparking this whole technological revolution.
Okay, so our story begins with a really fundamental dream, the dream of creating an artificial brain. And to even start, the pioneers had to think small, right? They had to start with its most basic component, the neuron.
And in the beginning, things moved incredibly fast. It all starts in 1943 with the first mathematical model of a brain cell. Then boom, by 1956, the field gets its official name at that now famous Dartmouth Conference, artificial intelligence. And just 1 year after that, the Perceptron is born. This was the first neural network that could actually learn from data. I mean, this string of successes sparked what we now call the first golden age. Everyone was so optimistic. And the Perceptron, well, it was a massive milestone. I mean, for the very first time, a machine could look at data, literally adjust its own internal wiring, and learn to recognize simple patterns. But, and this is a big but, hidden inside this incredible achievement was a critical fundamental flaw, one that was about to bring the entire field to a screeching halt.
So that initial wave of excitement, it just slammed into a brick wall of reality. Progress completely stalled, all the funding dried up, and researchers walked right into a period they now call the first AI winter. Yeah, the real showstopper came in 1969. Researchers proved that the perceptron couldn't solve this surprisingly simple logic problem called XOR. Now, think of it like this. XOR just means one or the other, but not both. It's a super basic concept, right? But the perceptron was just fundamentally unable to get it. And this one failure, it completely shattered confidence. And more importantly, it killed the funding that was driving all the research. So you had this huge gap between the hype and the reality. The dream was these amazing machines that could see and understand the world just like us. But the reality? The tech couldn't even solve simple problems that weren't, linear, problems you can't solve with just a single straight line. And this one limitation plunged the entire field into a kind of dark age, where progress just stagnated for more than a decade. Then came the thaw. The solution, which was actually rediscovered in 1986, was this brilliant algorithm called backpropagation. And it was the key that finally unlocked the power of multi-layered networks. For the first time, deeper, more complex networks could learn from their mistakes efficiently. They could finally crack the kinds of nonlinear problems the perceptron never could. Spring had finally arrived for AI. But you know how it goes. This new spring was pretty short-lived. By the 90s, progress had stalled out again. These new, deeper networks were just way too power-hungry for the computers we had back then. And honestly, other, less demanding machine learning methods started to look like a much better bet. So yeah, a second, even colder AI winter was setting in. And then, 2012. This is the year everything changed. It was like this perfect storm where three crucial things, we're talking massive data sets, powerful new hardware, and some key algorithmic breakthroughs all finally came together, creating what people call a Cambrian explosion in AI capabilities. And the moment that really changed everything was this annual computer vision competition called the ImageNet Challenge. You can think of it as the Olympics for AI vision. A new kind of deep neural network was entered into the competition, and honestly, nobody had any idea what was about to happen. Okay, so get this. The winning error rate was just 10.8%, and that belonged to a model called AlexNet. Now, to put that in perspective, the next best competitor was stuck way above 25%. This wasn't just a win, it was an absolute demolition. The entire field was never going to be the same after that. So how did they pull it off? Well, its success came from combining a really deep architecture with some clever new techniques. But the real secret weapon, the absolute game changer, was using powerful gaming hardware, GPUs, to speed up the computation by an incredible amount. And just like that, the third golden age of AI had begun. All right, so with image recognition now on a clear path to being solved, the next great frontier was obviously language. But the old models, the ones that process text one single word at a time, they were just way too slow and way too forgetful to handle the crazy complexities of human language.
And then in 2017, the transformer architecture showed up, and it completely threw out the old playbook. It abandoned that slow, sequential, one-word-at-a-time approach. Instead, it used this revolutionary method that let it process all the words in a sentence at the exact same time, understanding the full context in parallel. A total game changer.
And this core mechanism was called self-attention. It was introduced in a paper with the just brilliantly simple title, Attention is All You Need. And it was this single innovation that unlocked a completely new and much, much deeper level of language understanding for AI. And that insight just sparked an absolute explosion. The GPT series started scaling up at this breathtaking pace, leading to GPT-3, and then, of course, culminating in ChatGPT, the tool that put seriously advanced conversational AI into the hands of millions of people, seemingly overnight. Which brings us to the revolution that's happening right now, as we speak. The goal isn't just to get AI to talk anymore. It's to get it to think, to go beyond just matching patterns and actually start reasoning and acting on its own. Probably the best way to think about this shift is moving from what's called System 1 to System 2 thinking. You know, earlier models like GPT-3 were like our fast, intuitive, gut reaction System 1 brain. The new frontier is building a System 2, a slow, deliberate, analytical reasoning engine inside the AI. And the performance difference is just staggering. Look at these complex reasoning benchmarks. Where even advanced models like GPT-4o struggled, these new reasoning-focused models like OpenAI's o1 are making these massive leaps. I mean, in some cases, they're improving accuracy by an order of magnitude. It's wild. So this powerful new reasoning ability is exactly what's fueling the rise of agentic AI. We're talking about autonomous systems that can use tools like searching the web or writing code, then create complex plans, and then actually go and execute those plans to achieve a goal, all without a human holding their hand. So if there's one thing to take away from all this, it's that AI development has never been a straight, predictable line. It's been this dramatic story of booms and busts, of these brutal AI winters and these glorious, innovative springs. And with each comeback, it reaches these incredible new heights. And all of that history, all those decades of breakthroughs and setbacks, it all brings us right here, to today. And it leaves us with the single most important question as we step into this next chapter. Now that AI can reason and act, what are we going to ask it to do next?